If you wanted to be successful, do follow experts. Hi everyone, my name is Sheikh Hussain. I have been teaching chemistry for the past 22 years for IIT JEE, NEET and state board exams. In this video series, I am going to explain all important questions for intermediate for the students who are studying in Andhra and Telangana. I will provide short, simple and to the point explanation for all the answers to help you score full marks. The study material I am going to use in this video series is carefully prepared by my friend Santosh Kumar Reddy, PGT Chemistry. For regular updates, do follow my channel and join our WhatsApp group using link in the description. Hello everyone, in this video we are going to discuss the acidic nature of phenol and its comparison with alcohols. Explain the acidic nature of phenol and compare it with alcohols. Actually, this is also one of the important questions for 4 marks. Sometimes this question also may be asked for 2 marks. So when the question is asked for 2 marks, you no need to show all these resonance structures of phenoxide ion. If it is asked for 4 marks, it is better to write all the explanation given in this material, right? So here we have to compare the acidic nature of phenol and alcohol. Generally, what are acids? Any substance which gives hydrogen ions when dissolved in water is known as acid. What is an acid? Any substance which gives hydrogen ions, H plus ions, when dissolved in water is known as acid. So now we'll see whether alcohol and phenol can act as acids or not. Now first let's discuss how alcohol and phenol can act as acids. C2H5OH. This is called ethyl alcohol or ethanol. So ethanol generally loses this H plus ion. So this can be written as C2H5O minus and H plus. When it loses H plus ion, it becomes C2H5O minus and H plus. So by releasing this H plus ion, this can act as an acid. Ethoxide ion. Ethoxide ion is formed along with the hydrogen H plus ion will be released. Since ethyl alcohol is releasing H plus ion, it acts as an acid. And similarly, let's take phenol. Phenol OH gives O minus and H plus. Since phenol also can release H plus ions, it can also act as an acid. Phenol also has acidic character. Then what's the difference? The difference between the acidic character of ethanol and phenol is ethanol gives ethoxide ion, phenol gives phenoxide ion. Phenoxide ion. But this phenoxide ion is very stable in comparison with the ethoxide ion. The reason behind this is phenoxide ion is stabilized by resonance. That means it loses lot of energy and becomes stable, whereas phenoxide ion is not that much stable in comparison with phenoxide ion. So let's discuss what are the resonance structures of phenoxide ion. The resonance structures, we have to take one second. Let's take a phenol. Let's take a molecule of phenol. Here it has 3 alternative double bonds, and here OH, O bond, H. When it loses that H plus, it becomes phenoxide ion, right? And the bonds will be like this, and it becomes O minus and H plus. Do you know O minus, that is oxygen, is having already 2 electron pairs, and due to this minus negative charge, means one more bonded electron pair oxygen has got. Now oxygen is having 3 lone pairs. This is called phenoxide ion. This is phenoxide ion. Now we will see how this phenoxide ion is stabilized by resonance. Alternative double bonds, O minus, O minus. Now here this bond this negative charge is nothing but one electron pair comes between oxygen and the carbon of this benzene ring. Then here there will be formation of a double bond, and when this electron pair comes here, the electron pair present within the benzene ring, that is a pi electron, will come out. While it should come out due to the repulsion between this electron pair which is coming in between oxygen and carbon, and the electron pair, that is pi bond, is already present between these two carbons 1 and 2. Let it be first carbon and this is second carbon, between first and second. I will give the numbers to remaining carbons also, 3, 4, 5, 6. Then the electron will come out here. Then we'll get a new structure. Now here double bond is formed and this electron pair is coming out. That means here there will be negative charge here, negative charge. Here there will be negative charge. These two bonds already present here. These two bonds already present. Now whenever this electron pair again comes in, the already existing pi bond electrons will come out at this carbon. What is this number of this carbon? Carbon number 4. Then we'll get one more structure, that is O double bond. Here two bonds will be there and this electron pair is here, and this oxygen carries always two lone pairs, and we no need to discuss every time. Next, whenever this electron pair comes between these two carbon atom, and this electron pair will be repelled and moves to the next carbon atom, we will get one more structure like this. Here the negative charge will be at this carbon, and the double bonds formed here and here, double bond O, and this oxygen having two lone pairs. Now we'll see how the phenoxide ion gets stabilized. So now you can see here different resonance structures of phenoxide ion. So this is the first form, that this oxygen, you can see dots here. What are these dots? These are 3 electron pairs, 1, 2 and 3 electron pairs. Whenever this electron pair comes between this oxygen and carbon of the ring, that is this benzene rings, there will be formation of a double bond between oxygen and carbon of the benzene ring. Here there will be formation of double bond. How this double bond we got? So this electron pair coming between oxygen and this carbon atom, so we got one double bond here. And whenever this electron pair coming between oxygen and this carbon atom, already existing pi electrons in the ring will come out to the next carbon, because whenever these electrons are coming between oxygen and carbon, there will be repulsion between the already existing pi electrons and the incoming electrons. So this repelled pi electrons will go to the next carbon. So here we get one negative charge. Whenever this negatively charged electron pair and moves into the ring, and already existing pi electrons will move to the next carbon. So at next carbon we can see a negative charge. That means one electron pair is at this carbon, that is it. This is a 4th carbon. Actually, shall I give the numberings to this carbon so that you can understand easily? This is the carbon number 1, this is carbon number 2, carbon number 3, carbon number 4, 5 and 6. That means whenever this first electron pair comes between oxygen and carbon number 1, and the electron pair, that is pi electrons, moves to carbon number 2, so that we got negative charge at carbon number 2. So from carbon number 2, when this electron pair comes into the ring, already existing pi electrons will move to the carbon number 4. So at carbon number 4 we will get negative charge, and here there will be formation of a pi bond. That means these electrons coming in now, so here we will get one pi bond. So now whenever this electron pair which is at carbon number 4 comes into the ring, and already existing pi electrons at between 5 and 6 will move to the carbon number 6. So at carbon number 6 we get a negative charge. So here there is a formation of a new pi bond. and when the electron pair between carbon number 6 and 1 and moves into the ring, and the pi electrons between, that is a pi bond between oxygen and carbon, moves again onto oxygen atom, and we will get the structure which is very similar to the first one. Actually, if you observe, the first structure and the last structure both are very similar, only the difference is the positions of pi bonds. Here the position of pi bonds, you see, between first and second carbon atom there is a pi bond, between third and fourth there is a pi bond, between fifth and sixth there is a pi bond. But here the thing is different. Here the pi bonds are between second and third, fourth and fifth, sixth and first, right? So that means these electron pairs, that is pi electrons, moving inside the ring, and after getting this final structure, this is not stable again the same process will be reversed, and next this molecule is converted, this phenoxide molecule will be converted to this form, and this form is converted to this and this, and again we will get the first form. Again this first form is shows the different resonance structures, we will get this. That means all these structures are interconvertible and resonating from one form to another form. During this electronic transition from one place to another place, the molecule loses, the species loses lot of energy, and it will become more stable. So due to the resonance hybrid structures of phenoxide ion is more stabilized. So when the ion is more stabilized and its acidic nature will be more, so that the phenol is more acidic in comparison with alcohols. Any substance which gives hydrogen ions when dissolved in water is known as acid. Phenol undergoes dissociation to give H plus ion and phenoxide ion in water, right? That we have seen already. See here, when phenol undergoes dissociation, it gives phenoxide ion and H plus ion. So it is considered to be an acidic nature, right? Hence phenol is acidic. The acidity of phenol is more than that of ethanol. This is because the phenoxide ion formed after removal of hydrogen ion exists as resonance hybrid of 5 structures. Actually, whatever the explanation I have given to explain these resonance structures, just to make you understand, you no need to write all this explanation, just you need to write points related to the question and these resonance hybrid structures. The main content here is what are acids. Acids are those which gives hydrogen ions when dissolved in water, and next phenol is more acidic in comparison with ethanol. This is because phenoxide ion is stabilized due to resonance hybrid structures. That's all. This is a very simple answer. In the case of alcohol, there is no resonance, and both alcohol molecules and alkoxide ions exist in only one structure. Thus phenol is more acidic than alcohol. Alcohol and alkoxide, that means in the previous few minutes back I explained you, this is alcohol, ethanol and ethoxide. Generally when it comes to organic chemistry, I may take little more time to explain you and to make you comfortable with the explanation, but in actual practice the answer you need to write is very less in comparison with my overall explanation. Okay, I hope you understood this topic, and we'll discuss the next question in the coming videos.